new material. All right. So we are solving quadratic equations. This is a new concept that we will assess next week, solving quadratic equations. Now, the method by which we're going to solve these equations is by factoring. Well, we've learned how to factor over the last couple weeks, so we'll use our knowledge of factoring quadratic to see how we can solve equations that have quadratics in them. We have not done this yet before. Okay, in order to solve quadratics by factoring, we need to learn a really important property. It's called the zero factor property. Now go ahead and take these notes along with me. Everything I write, you should write. Okay, the zero factor property. Let's illustrate the zero factor property. If I have two numbers that are being multiplied to equal 0, well, the only way this can be true, the only way a times b can equal 0, the only way two numbers multiplied together can equal 0 is if at least one of those numbers is 0. Right? In order for a times b to be 0, then either a or b must be 0. In order for two numbers multiplied together to be 0, one of those numbers has to be 0. That's the only way you can multiply to get 0. That is a very simple yet very important property which will allow us to solve quadratic equations. So I'm going to go through 5 examples, and then you'll have 3 to practice. So example number 1. Here's a quadratic equation. Okay, notice that we have a quadratic. It's a second-degree polynomial. Now, to solve this, we can't use our old methods, right? I can't combine these two terms. I can't, take the square root of both sides because we don't know what the square root of x squared minus 6x plus 6 is. So in order to solve this, we're actually going to factor. Well, this is a quadratic trinomial on the left, so I'm going to use my Xbox method. So let's just factor this real quick. I need two numbers that multiply to get 6 and add to get negative 5. Well, that is negative 3 and negative 2. So I plug in into the box and factor. So the two factors are x minus 3 times x minus 2. Okay, now we can use this zero factor property we just talked about. The only way this factor times this factor can equal 0 is if either the first factor or the second factor is in fact 0. So what we do here is we set each factor equal to 0 and solve. So here, x equals 3, and here, x equals 2. So this equation actually has two solutions. There are two numbers that satisfy this equation. Let's do a quick check. So I'll check the first one. Let's see if 3, when I plug in for x, satisfies this equation. 9 minus 15 plus 6. Well, let's see. 9 minus 15 is negative 6 plus 6 is 0. It checked out. Let's try it for the other one. 2. So let's plug in 2 and see if it satisfies this equation. So that's 4, that's negative 10, and that would be negative 6 plus 6 is 0. Yeah, it checked out. So quadratics, we'll learn, can have up to 2 solutions. In this case, the 2 solutions were 3 and 2. And the way we solved was by factoring and then using the zero factor property. Let's do another one. There we go. X squared minus 6 equals x. Okay, in this case, this is a quadratic equation, once again, because it's second degree. Now, in order to solve a quadratic equation by factoring, we first want to put it in standard form. Well, what's standard form? Standard form is this. It's when we have all three of our terms on the left equal to 0. So in our case, we need to subtract x from both sides. So now we have x squared minus x minus 6 equals 0. Now that this is in standard form, meaning all the terms are on one side with a 0 on the other side, we're ready to factor. Okay, if I factor this, I need two numbers that multiply to get negative 6 and add to get negative 1. Well, that's negative 3 and positive 2. So this factors to x minus 3 times x plus 2. Now, by the zero factor property, the only way x minus 3 times x plus 2 can equal 0 is if at least one of those two factors is 0. So we set each factor and say, well, what happens if it is 0? What would x have to be? Well, here x would have to be 3, and here x would have to be negative 2 if I solve those. We could check, and this would work out. I'll do a quick check with one of them, just to show you that it works. Let's plug in 3. 3 squared minus 6, does that equal 3? 9 minus 6, does that equal 3? Yes. And it would work if we plugged in the negative 2 as well. Let's do another one. 4a squared minus 8a plus 4 equals 0. Okay, this is nice because the quadratic is already in standard form. It's already equal to 0. Remember, that's the first step we have to take. Now let's solve. And we're solving by factoring, remember. Oh, and I look at these three terms and notice that there's a GCF of 4. Always factor out a GCF if you can. So I factored out the 4. Now the nice thing about solving an equation here is I can actually divide both sides by 4. Because on the left-hand side, 4 divided by 4 is just 1. So we're left with a squared minus 2a plus 1 equals, and 0 divided by 4 is just 0. So that kind of made things cleaner and simpler. When you're solving an equation, you can divide by that GCF, and that will cancel out on the left and give you 0 still on the right. Now I can factor this. Now, hopefully you're starting to see that in order to factor this, we need two numbers that multiply to get 1, but add to get negative 2. Well, those two numbers are negative 1 and negative 1. So this factors to a minus 1 and a minus 1. Now that we have our factors set to 0, we can solve by using the zero factor property. If I solve this and add 1 to both sides, I get a equals 1. And actually, I get a equals 1 again. So here we have one answer that appears twice. The vocabulary for this is a multiplicity. So we have one answer that appears twice. So in this case, we have one answer, a equals 1. That's the only number that satisfies this equation. If we plug in 1, we'll see that yes, it will make the equation true. All right, let's do another one. This will actually be the last one that I do with you. Number 4. 2n squared equals negative 35 minus 7n. Now, I notice that I don't have the equation equal to 0, so I need to move everything over here to the left. So I add 35 and I add 7n to both sides. Those cancel, of course. So I'm left with 2n squared plus 7n plus 35 equals 0. Now this is in standard form. We've got our squared term, then our to the first term, and then our constant term. Now, let's see, can I factor out the 2? No, 7 and 35 are not divisible by 2. So I don't have a GCF, so I need to factor this. So we have 2n squared and 35. So I need two numbers that multiply to get 70 and add to get 7. Hopefully you saw where that 70 came from. we had to multiply the leading coefficient with the constant term. Now, what two numbers multiply to get 70 but add to get 7? Well, 1 and 70, no, that doesn't add to 7. 2 and 35, no. Let's see. 7 and 10, no. All right, we could sit here all day and look at all the pairs of factors of 70, and we'll see nothing adds up to 7. So this is not factorable. So for now, we'll just write not factorable. Later, we'll see that we can solve quadratic equations even if they're not factorable. But for now, every once in a while you may see something that's not factorable. I'll just go ahead and write not factorable and move on. Okay, so I've got 3 practice problems for you. I want you to copy down these 3 problems, try them, and then pause this video while you try them, and then I'll go over the solutions for you to check your work. All right, so go ahead and pause the video and try these 3. Once you're finished, press play so that you can check your work. All right, hopefully you've given these 3 a go. Let's see if our answers align. I put this into standard form. I factor. 2 numbers that multiply to get -6 but add to get -5 are -6 and +1. I set each factor equal to 0, and I solve for x. So our 2 answers are 6 and -1. For number 2, this is already in standard form. I can't factor out the 3, so I go ahead and try and factor. It's too small. Zoom in here, okay. So 3x squared and 8. I need 2 numbers that multiply to get 24 and add to get 2. And there are no 2 numbers that multiply to get 24 and add to get 2, so this is not factorable. Number 3. All right, if I factor this, I'm going to get x minus 3 and x minus 3. By the 0 factor property, I set each factor equal to 0 and solve. So I get x equals 3 with a multiplicity of 2, meaning it happened twice. So our answer is x plus 3. You could just leave it like this, x plus 3 and x plus 3. We know there's one answer. The answer is 3. All right, hopefully you did well with those. Now you can go ahead